So now in this video we are going to start with the construction and working of the electric bell. So here we are going to start with the electric bell, and electric bell is a device which is capable of producing a characteristic sound. So here we are making use of an electromagnet, which means the temporary magnet, and here we are using the U-shaped magnet. Here we are applying the U-shaped magnet. So let us straight away start the circuit diagram, and then we'll see the construction part. So this is the U-shaped magnet. The wire which we would wound is such that on one pole the wire should be wounded in the clockwise direction, and on the other we have to wound the wire in the anti-clockwise direction, because we know that it has to obey the clock rule, and that would be obeyed only if the winding is opposite and the current would also be opposite. So where it is clockwise it will form the south pole, and where the current is anti-clockwise will form the north pole according to the clock rule. So we are just making this coil clockwise over this side and anti-clockwise over this end. Alright. So there is a metallic strip which is attached to here. This is the metallic strip which is attached over this side, and to metallic strip there is the attachment of the armature. So this is a long armature which is, you would say, present along the metallic strip. This is further attached to the hammer. This thing is further attached to this hammer, and this hammer will be striking the gong. A metallic thing, this is the gong. Alright. There is a very important component here, which is the adjusting screw, through which the circuit has to be completed. Now let us see how these windings they are connected. Windings they are connected by making the use of these two terminals to the external circuit. Now this winding, this is directly connected to this terminal. This is directly connected to this, which is further connected to the external circuit. And the connection is made through armature, then through metallic strip to this, and further from the adjusting screw, the wire is passing through this terminal and it is connected to the external circuit. This external circuit is having only and only two things. One is the battery and this is the tapping key. This tapping key should be pressed once. It will automatically come back to its original position. So we'll have to just tap it for switching on. It will automatically be switched off. So this, let me just now label these part. Let me just make it a little bit of consolidated, because we'll have to make the boundaries of this. So this all apparatus I am bounding into a box. So this is the complete electric bell. So this electric bell is having a gong. This is the hammer. This is the adjusting screw. This is the adjusting screw. This is the metallic strip. Metallic strip is having spring system. Metallic strip is having the spring system. This is the, simply we can say, battery. This is the tapping key. These two are terminals, terminal 1 and terminal 2. This is the soft iron core, which will be becoming magnet when the current is being passed. Alright, so this is all about the construction of the electric bell. The thing is how the connections are made. This winding is passing through terminal this T2 and is connected to the external circuit. This winding is first connected to armature. Let me label armature. This AB is the armature, and armature is made up of iron. So this winding is making the connection with armature AB, which is further connected to metallic strip, and then the connection is made through this adjusting screw and it's passing through this terminal. So this is how both windings they are connected. Which means this metallic strip, the armature and adjusting screw, they are very important component of the circuit also. Alright, let us now just start with the working part. So in working, when the key is pressed, when the tapping key is pressed, the circuit will now be complete. The circuit is complete, the current will start to flow from the circuit. Alright, it is flowing from here, then it is passing through this, it will be taken up by this coil, then it will be moved back to the circuit. So this is how the flow of current is. Now when the current is flowing, according to the clock rule, whenever the current passes through a coil, a pole is formed. If it is clockwise rotation of the current, then it will form south pole. If anti-clockwise, then it will form the north pole. So accordingly, the two poles will be formed, and the formation of two poles means it is going to act like a magnet. The similar pole will be present in the soft iron core, as we have discussed in the U-shaped electromagnet part in the previous video. So what I am saying is, by passing the electric current, the soft iron core is now magnetized. Now, if it is magnetized, it is going to act like a magnet, a true magnet. This armature, which is made up of iron, will be attracted. This armature is attracted towards this magnet. So this armature will displace its position and it will get attracted towards this. It is going to attract like this. So this armature will come to this position. From this, it is going to displace and come to this position. Now when this happens, the hammer is connected to armature. This hammer will also move forward and this hammer will strike the gong, and this is going to create a characteristic sound. Sound is produced when this hammer is striking the gong. Alright, sound is produced. Now how it will come back to its original position, so that when the next tapping key or when the next tapping is done, it will again move forward and produce sound. See, when it is moved forward, the connection is now broken. Why? Because this connection is made through this armature. The connection of this winding is made through this this armature. The connection is made through this armature. If this armature is getting displaced from its original position, the circuit will now not having that component which was making the circuit complete. It has displaced to its from its original position. So what will happen? That component is missing, which means the circuit is open. If the circuit is open, the current will no longer be flowing. If the current is not flowing, this soft iron core is getting demagnetized. If this is getting demagnetized, this is no longer remains magnet. This iron will no longer be attracted towards this. Then how it will come back to its original position? There is a spring system which is attached to this armature. When it has moved forward, the spring has just extended. So that spring is having its restoring force. When that magnetic effect it decreases, the attractive force it decreases, the restoring force will pull the armature towards itself. So this armature is pulled by the restoring force of the spring. So this is how it will come back to its original position. When it comes back to the original position, the tapping key is pressed. The circuit is again complete. Circuit is complete. The current will flow. It will get magnetized. The hammer will strike the gong. The sound is produced. Again, the circuit is open. The circuit will break. The current will stop. Demagnetized. No more remains magnet. The spring will come into action. It will pull armature to its original position. So this is how the continuous action of the electric bell would be. Alright, there is one important question. What will happen if battery is replaced with AC? If battery, which is the DC source, it is replaced with AC source. So what will happen if this battery, which is a DC supply, direct current supply, is converted to AC supply? We know AC current changes its direction continuously. AC current, it changes its direction continuously. If it changes the direction of the flow of current, then direction of current changes, then poles will continuously be changing. The north is becoming south, south is becoming north, again north is becoming south, south is becoming north. Why? Because alternating current, it continuously changes its direction. If the direction of current changes, the clockwise rotation become anti-clockwise, anti-clockwise become clockwise, and that is why north will become south, south will become continuously. But the thing is, here we are only concerned with the magnetization of this soft iron core. If the outside current is passing, this soft iron core is getting magnetized, whatever polarity it is. Even if the polarity is changing continuously, this soft iron core will remain a magnet. The armature will be attracted towards this magnet. The hammer will strike the gong and the sound will be produced always. So, what I want to infer, or what is the conclusion? Even if we use AC supply, the working of the electric bell will not change. It will work even if the supply is changed from DC to AC, because we are not here concerned with the poles. We are here only concerned with the soft iron core getting magnetized. So this was all about the electric bell, its construction, working, and how it is going to affect if battery is replaced by the AC supply. From the next video, we are starting with the very important concepts of this chapter, which includes the DC motor and AC generator. So in the next video, we'll start with the basics as the Lorentz force.